Hey guys, welcome back. So in today's video, we're going to be working with doubly linked lists again, but this time we're going to be working on the delete function, and it's pretty self-explanatory. If we have a list like this where we have A, B, C, D, E, and we want to delete the D node, we want to return a list so that our D node is gone, our C is pointing to the none, and our D node is basically nowhere to be found. And so there's going to be sort of two edge cases we'll deal with, one for if it's a last node and one for if it's the head node. And other than that, let's get started. If you guys want, pause the video and try it on your own because that's the way you learn the best. But if not, come back and we'll work through it together. And so the first thing I'm going to do is I'm going to say, first I'm going to handle for if not self.head print list is empty. And so what this is going to do is if we ever want to delete from an empty list, we're just going to say the list is empty and then we're going to return. Other than that, we're going to say cur is equal to self.head so that we can start off at our head node and we can loop through. And we're going to say while cur, if cur.data is equal to the data. So in this case, we're checking if the data element of our current node is equal to the data parameter that we passed, because that means that's a node we want to delete. If it is equal, first we want to check if it's a self.head. And so we'll say if cur is equal to the self.head, we're going to say self.head, sorry about that, self.head will be equal to self.head.next. And so what we're doing here is that we're saying that if we want to delete this head node, we want to simply say that our self.head should move to our next node, or the next node after our head, and we're just going to keep looping after that because that is what we need to do. We'll also say that then our self.head.prev will be equal to none. And so what this is doing, like I said before, this is going to loop through and we're going to say that our head element should move over to the B because this head node would be one that we want to delete. And so our new head node will be the B node. And then we also need to change the prev element of this new head because this prev element would be pointing to B, pointing to the A. And so you want this B node, the prev element, to point to none. And so we're just going to be saying that our self.head.prev will be equal to none. And so by this line of code, we will have replaced what our self.head is. And so that is if our head is, the node is a self.head. If it isn't, what we're working with is say we take this C node, for example, right? We want to say that our B node should point to the D, and then the prev element of our D node should point to the B. And so that's going to basically erase our C in that instance. And so what we're going to say is our cur.prev.next. So the cur.prev is referencing the node that comes before this current node, and then the .next is referencing the next element of that previous node. We're going to say that is going to be equal to the cur.next. And so we're going to say that the previous node should point to our current node's next element. And so if our C was a current node, our cur.prev is the B, and the next element of our cur.prev should then point to the D, which is the next element after the C, which is what the cur.next is. And so that is handling for rerouting the previous arrow. The next thing we want to do, we want to handle for if this node is the last node. And so if this is the last node, we can't say that our the next element, the prev element of our next node should point to our cur.prev because that the next element would be none. And so what we want to say, first we want to check if there's a cur.next, because if we're checking the C node, in this case we can say that the prev element of our D node should point to the B. But if we want to delete this D node, we can't say the prev element of our none should point to our C node because there is no prev element for our none. So first we want to make sure that there's a cur.next. So then we can say our cur.next.prev which is the cur.next is referencing the next node, and then the prev is referencing the prev element of our next node, it should equal, or it should point to our, cur.prev. And so all this is saying is if we're at the C node, we're saying that our cur.next, which is a D, the prev element of this D node should then point to our B. And that's going to erase our C node all in all. And if our current node, the data element of our current node is not equal to the data parameter we passed, we're just going to move over to our next node. And that is going to be handling, or that's going to be the end of deleting our node, or the end of the delete function. So we'll test that out. I have a couple different cases here. First, we'll make sure that our ABCD works. And so we'll just say Python ABCD. And so we get our ABCD. And then what we want to do, we want to delete the head node. So if I run that again, we only get a BCD. And so what that's doing is our first node, the data element of our first node is equal to the data parameter that we passed. And so we're just checking if it's a self.head. If it is, we're just going to move our head node over, and that's just going to remove our self.head. And so that is for that. We'll test removing something in the middle, which would be the B, because if we look at this, there is a node before and after our B node. And so that is going to be a sort of different case. That's going to be using these cases. And so if we run that, hopefully we get ACD. And so what's happening in that case is our cur.data is equal to the data parameter that we passed, except we're going to be running these lines of codes. And so like I said before, this is referencing the previous node, which in this case would be the A. And we're saying the next element of the A should point to the C, which is the cur.next of the B. And if we have cur.next, which in this case we do is the C, we want to just say that our cur.next.prev, this is referencing the prev element of our next node, this should then point to the A. And so then neither our prev node or our next node will be pointing to the B at all. And so that's just going to remove our B from the list. And that is running through that case. And I'm just going to test deleting the very last node to make sure that this doesn't work, or this doesn't run. And so in that case, that would be the D. If we run that, we get ABC. And so once again, we're just rerouting where our prev node points to, and then we're checking to make sure there's a cur.next. And since this case there isn't, we're not even going to run this line of code, and we're just going to move on to our next node. And so then our cur will be equal to none, and our while loop will finish. And so that is those different cases. I'm just going to first delete everything to make sure we return an empty list. Oh, we don't need that line of code. I'll run that. We get it. We don't print out anything, and so that is that indicates that we don't have anything to print. And one thing I want to run is this line of code. And so what this should do is, if we have an empty list like we do in this case, we should print out this, that the list is empty, because you can delete from an empty list. And so if we run that, we get that our list, we see that it's printed out, our list is empty. And the very last thing I want to test out is if we delete, say we just delete our B and C nodes, if we try to delete our F node, that should obviously not delete anything, so I just want to make sure. And so we delete B and C, and our F delete function doesn't do anything. And so it loops through everything, but we never have to delete anything. And so we just say that we just keep looping through our cur, and until we get to the end of the list, we just keep looping, and once we get to the end, we just end the while loop, and that's the end of the function. And so that is the delete function for doubly linked lists. Hopefully that helps you guys, and see you guys in the next video. All right, later.